Alright, in today's video, we are going to learn about simplifying radicals. And by the end of this video, I want you guys to be able to answer the question in your summary of how do I simplify a radical to an equivalent form. Before we start looking at radicals, and we look at what radicals are composed of perfect squares of the integers. So on the side of your paper, we're just going to go through the perfect squares of the integers. I would highly recommend you guys have these memorized. I'm going to push you guys to memorize all the way to 15 squared. So we got 1 squared, that's 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. And so on. I'll let you guys use your calculator to figure this out. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. And then 13 squared is 169. 14 squared is 196. And 15 squared is 225. So the property that we're going to use is that if I have two numbers multiplied together under a radical, let's say a and b, that I can break this radical up to square root of a times square root of b. So let's see how I'm going to use that in my first example. So if I have the square root of 36, we want to simplify this to equivalent form. Well, square root of 6 actually is a perfect square, so we don't really have to do any simplifying for that. It already is one of our perfect squares, and the square root of 36 is just 6. In the second example, we're going to square root of 40. So in order to do this, we're going to look for perfect squares that go into 40 evenly, without a remainder. So obviously 1 will, but we're looking for something a little bigger. Well, 4, well yes, 4 will. So if I do that, I got the square root of 4 times 10. Now I'm going to use that property I mentioned above in the white, and I'm going to say, okay, well I could break that up into square root of 4 times square root of 10. And similar to my example in the purple, we're saying, okay, so we already know the example, square root is 4. So square root of 4 is 2. And we're left with 2 square root 10. And these two are exactly equivalent. If I show you guys on my graphing calculator, if I have the square root of 40 and I have 2 square root 10, I will get these out to be the same exact value. So these are equivalent forms, just different ways of writing the same exact radical. Let's look at one more. If I look at the square root of 12, square root of 12 can be broken up into square root of 4 times 3. And I can also break that up into square root of 4 times square root of 3. So I get 2 square root 3. And I can say that my conclusion that the square root of 12 equals the square root 2 times the square root of 3. To demonstrate again, we're going to have the same thing. If I put the square root of 12 in here, I'll get 3.464 somethings. And if I do 2 square root 3, get the same exact thing. All right, let's look at something a little more difficult and something more likely to show up in any math practice that we have. Let's look at the square root of 80. Well, if I'm looking for numbers that go into 80 perfectly, I can start with, well, I know 4 will work, because if I do 80 divided by 4, I get a perfect number. So let's try that to start. If I break this up into square root of 4 times 20, and I can break that up into 4 times square root 20, and now the square root of 4 is 2, so that's 2 square root 20. But if I look at 20, 20 also has perfect squares going into it. So if I have the 2 square root 20 and I broke up the square root 20 part, I could break that part up into leaving the 2 out front, the square root of 4 times 5, which is the same thing as 2 times square root 4 times square root 5. And we know the square root of 4 already, that's 2, so we have 2 times 2 times square root 5. And we're going to combine these like terms. Since they're both outside of the radical, we can combine them. 2 times 2 is 4 square root 5. Now, is there a simpler, more precise way to get that to this answer? Well, the answer is yes. Instead of using 4, we can look at bigger perfect squares. Let's try 9. Does 9 go into 80? We got 80 divided by 9. Well, of course it doesn't, because 9 goes into 81, so it's not going to go into 80 as well. Let's try 80 divided by 16. I get 16 and 5. And I know that that's going to be my biggest perfect square, because no other perfect squares can go into 5. So that's a simpler, easier number we could use. So if I want to break square root of 80 up into 2 numbers, let's try 16 and 5. So square root of 16 times square root of 5. Well, square root of 16, we know that to be 4, and we have square root 5. And look at that, we have the same exact answer. Just in this method, it took a lot less work because we were more precise of looking for the biggest perfect square. Let's do one more example together before this video ends. I'm going to do the square root of 288. So again, we can look for numbers that go into 288 perfectly. You might say that 288 can be divisible by 4 times 72, because that's the first perfect square that you got. And you can do that. You're going to get 2 square root 72. But 72 also has perfect squares that go into it. So if we break that up more, we'll get 2 times 72 can be multiplied by 36 times 2. If we break that up to 2 times square root 36 times square root 2, and break this radical up to the 2 of them, then we get 2 times 6 times square root 2, which is 12 square root 2. Because 2 times 6 gives me the 12 right here. And the 6 came from the square root of 36. But with 288, there's also a much simpler, quicker way to do it. I'd recommend, again, looking for the biggest perfect square that goes into whatever's underneath the radical, which we call the radicand. In this case, a much simpler way to do it would be 144 times 2. When we break that up, we're going to square root of 144 times square root of 2. And we know that square root of 144 is the value 12. If I didn't know that, I could definitely pull out my calculator. I can do that computation again. Remember, it's second x squared, and we type in 144, and we get the value 12. We got 12 square root of 2. And again, I could plug this in my calculator. As I see it, get the same exact answer. Whether I take more steps, or if I'm better at looking for patterns, I can make my work go a lot easier with fewer steps. That concludes our video. Make sure you guys answer the question in your notes. In your own words, how do you simplify a radical to an equivalent expression?